Have you ever felt like you're just drowning in data when you're coding? Well, you're in exactly the right place. Today, we're going to take that classic coding roadblock and turn it into your new programming superpower. We're going to master Python lists.
So here's how we're going to do it. First, we'll look at a really common problem. Then we'll introduce Python's awesome solution for it. After that, we'll get into how to access and change your data, and finally, see how it all works in the real world.
All right, first things first. Let's talk about a classic coding headache, something every single programmer runs into, having way too many variables.
I mean, think about it. How would you actually store 100 different names in your code? Or what about 1,000? If you're building an app with a list of users, you need a smart way to handle a collection of items that could grow at any moment.
Sure, you could try making a new variable for every single name, but you can probably see where this is going. It gets messy fast. It's just a total nightmare to manage, and it absolutely does not scale.
So yeah, that old way is a no-go. But don't worry, because there is a much better way. Python gives us a really elegant solution. It's called the list.
So what is a list? Well, you can just think of it as a super flexible container for all your data. You make one with a simple pair of square brackets, and suddenly you can hold all sorts of stuff, all under one single, easy-to-manage variable.
Now, Python lists basically have three superpowers. First, they're ordered, which means the way you put things in is the way they stay. Second, they're dynamic. They can grow or shrink whenever you need them to. And third, they're heterogeneous, which is just a fancy way of saying you can mix and match different data types, like text and numbers, all in the same list. Pretty cool, right?
Okay, so you've got this awesome container and you've packed your data inside. Now what? How do you get specific things back out? Well, that's where something called indexing comes in.
You've got two main ways to grab items from a list. You can use positive numbers, which start counting from 0 at the beginning, or, and this is super handy, you can use negative numbers, which start from -1 at the very end of the list and count backwards.
Seriously, using negative indexing is a total pro tip. It's the quickest, most reliable way to get the last item in a list without ever needing to know how long the list is. Think about it. Grabbing the latest comment on a blog post or the most recent log entry, this is how you do it.
But what if you need more than just one item at a time? No problem. For that, we use something called slicing. It lets you grab a whole chunk or a slice of the list all at once.
Now, here's the one thing you have to remember about slicing. It's the golden rule. The starting number is included, but it stops just before the ending number. So a slice of 1 to 4 is going to give you the items at positions 1, 2, and 3, but not 4.
Okay, storing data is cool, but here's where lists get really powerful. They're alive. They aren't static. You can change them on the fly. Let's see how we can add, remove, and even organize our data.
So here are your go-to tools. You can use .append to tack a new item onto the very end. If you need more control, you can use .insert to add an item at a very specific spot. And .pop is fantastic. It removes an item, but it also gives it back to you, so you can save it to another variable if you want.
And what happens if your list gets all jumbled up? Easy. You can instantly organize it, alphabetically or numerically, just by using the .sort method. Now, one key thing to remember here is that this changes the list in place. It modifies your original list directly. Okay, I have to give you a quick warning, because this is a classic Python trap that gets almost every single new programmer. It's all about what happens when you try to make a copy of a list.
Listen carefully. If you just use an equal sign, like B equals A, you are not making a copy. You're just sticking a second name tag on the exact same list. That means if you change B, you're also going to change A. To create a truly separate, independent duplicate, you absolutely have to use the .copy method.
All right, that was a lot of the how, but what about the why? We've covered the mechanics, but why does any of this actually matter? Where does this stuff show up in the real world?
The truth is, lists are literally everywhere. They're perfect for keeping track of users in a web app, managing a player's inventory in a game, holding rows of data you want to analyze, or even just making a simple to-do list. They are a true cornerstone of programming. So there you have it. You now have the essential toolkit to start building much more complex, much more dynamic programs. You can handle collections of data like a pro. So I'll just leave you with this one final thought. With this new power in your hands, what problem are you going to solve? What are you going to build first?